Okay, question number 10 is probably the hardest question on the paper. It's a big 9-mark question. It's told us that we've got some sort of cubic, but the only thing we've been told is that it's a 1x cubed. We don't know any of the other coefficients of the equation, but we are told that this is a point on the graph, and that you can see it's a maximum point, and we've got its coordinates, and we're also told that it goes through 3, 0 as another point. So there's a couple of ways you can approach this question. Initially, what I thought to do was come up with a set of 3 simultaneous equations. We've got 3 unknowns here. So if we can substitute in these values, we'll get some equations with P, Q and R. But on reflection, I've just realised that this point and this point will allow us to write the cubic in factorised form. We can straight away say we've got a repeated root here, so that in factorised form would be x plus 1 squared, and we've got a point of intersection here. It goes straight through the graph here, so that will be x minus 3. So if we expand those brackets, that will give us the expanded version, and therefore we can just read off P, Q and R. The first bracket expands to x squared plus 2x plus 1. So then if we incorporate the second bracket as well, we're going to get x cubed, which we're expecting. We're going to get minus 3x squared. We're going to get a plus 3x squared, a plus 2x squared. We are going to get a minus 6x, a plus x, and a take 3. And the reason I've written it like that is because you can then just add up the columns and get the full equation. X cubed take x squared plus minus 5x minus 3. So we straight away, in very few lines, have actually come up with the full equation. So what's the rest of the question wanting? It says find the values of P, Q and R. We've done that. We've got the P, probably should write that down. P is minus 1, Q is minus 5, and R is minus 3. And find the minimum point of the curve. So now we're after this point. So that's just the stationary point, and we already know one of the stationary points. So if we now differentiate this, dy by dx is going to be 3x squared take 2x take 5. We can set that to 0. We know one of the brackets is going to have to be x plus 1, so that's going to help us factorise this. That should make the second bracket a minus 5. Let's check if that works. So we're going to have minus 5x plus 3x is minus 2. Yeah, that's right. So the other stationary point is going to be at x equals 5/3. We know it has to be the minimum point because it's the only other stationary point of the cubic, and we already know that this is a maximum point. So the last job now is to just find the y coordinate to go with the x coordinate. We can substitute it into here, or we could substitute it into here. It's a bit of a pain to substitute it into either of them. I'm going to substitute it into the factorised form. I think that will probably be a little bit easier. So we're going to have 5/3 plus 1 squared times 5/3 take 3. That's going to give us, so this will be 8/3 squared times by, I'm going to write that as 9/3, so 5 take 9 is minus 4/3. So we're going to have a negative number, which we're expecting. It's negative a y value. So that's going to be 64/9 times by -4 over 3. 64 times 2 is 128, times 2 again is 256, and that's going to be over 27. So the minimum point is going to be at 5 over 3 minus 256 over 27.